This video was made possible by Assassin's Creed Origins, which is out today. When we think of ancient Egypt, most imagine sand-swept plains with giant pyramids jousting up from the barren desert, juxtaposed next to the lush meandering Nile, spilling nutrients into the surrounding floodplains to feed this burgeoning empire. But all we have for reference for this vision of the past are the ancient monuments and artifacts that remain, and ancient hieroglyphs that puzzle linguists for centuries. The ways of this ancient world is shrouded in mystery, so when I was invited out by Ubisoft to get a private tour of the British Museum, speak with historians, and get hands-on experience with their 3D explorable vision of ancient Egypt in Assassin's Creed Origins, to learn more, I jumped at the opportunity. Today, we're going to explore this ancient world and try to uncover one of its greatest secrets: how a civilization without power machinery managed to build those gigantic, godly structures. In our modern world, these structures may seem to some as just huge piles of rock. With modern machinery, like cranes, it may be easy to take for granted the monumental task of moving and lifting this much material. So let's put this problem in context to understand why it has baffled historians for centuries. The largest of the Great Pyramids, Pyramid Khufu, was the tallest man-made structure on Earth for almost 4,000 years. Pyramid Khufu contains over 2.3 million limestone blocks, each weighing an average of 2.5 tons, which form the interior structure of the pyramid. And an additional 200,000 blocks were used for the smooth white stone casing, which now only exists on the upper cap. But the pyramids aren't simply giant piles of limestone arranged nicely. Pyramid Khufu, incredibly, contains massive interior chambers like the King's Chamber, which is supported by massive granite beams, with the heaviest weighing about 40 tons. That's about the same as the maximum allowable weight of a fully laden articulated truck. These stones are located between 43 meters and 65 meters up the pyramid. Just transporting the massive stones to the site from the quarries was a massive undertaking, but other civilizations that predate the Egyptians have achieved similar feats, like Stonehenge or the even more ancient Irish building of Newgrange. The limestone for the pyramids was quarried nearby, much of it quarried directly next to the pyramids, while the granite was likely taken from Aswan and transported to the site on boats. We know from hieroglyphs that the Egyptians used wooden sleds to transport heavy objects, while workers lubricated its movement with water. This was simply a problem of manpower, which the wealthy Egyptian empire was not short on. What has fascinated me is the logistic challenge of building a structure like this. The sequence of events and mechanisms that these ancient engineers used to lift these immense weights into place are a mystery that many have tried to solve, but many theories come up short. To solve this riddle, let's start with what we do know. First things first, unless the pyramids were truly built by aliens with anti-gravity machines, the pyramids were built from the bottom up. Next, because of the precise geometric shape of the pyramids, with each side of the Great Pyramid being 230.3 meters long, with the largest difference in length between the northern and southern edge at only 4.4 centimeters. This level of accuracy could only have been possible if the external casing stones were laid first, allowing deviations to be caught early and corrected before the internal structure was filled in. This makes any theories for external ramps or cranes unlikely, as they would have been extremely difficult to attach to the smooth external wall, which was inclined at 52 degrees. Instead, the most prevalent theory suggests a ramp on one side of the pyramid that would raise with the pyramid, but this has its limit. When pulling a weight like this uphill, the force required is given by this equation. The average mass of blocks was 2.5 tons, or about 24,500 newtons. There were heavier blocks, but these were mainly used in the lower levels. Let's set our slope angle alpha at 7 degrees, and the coefficient of friction between two pieces of wet wood is about 0.1. Using these figures, we can calculate the force needed to pull this weight uphill at about 5,418 newtons. Modern safety guidelines say the maximum any worker should pull is 225 newtons, but since this is a prolonged track and stopping is not an option, most calculate the max each worker would pull at 150 newtons, or about 15.3 kilograms. So that means around 36 workers would be needed to haul this weight. This figure is reasonable, but for every additional degree of slope, at least an extra 3 workers will be needed, which would soon become extremely impractical. The other option of simply elongating the ramp and maintaining the angle is completely unfeasible, as constructing the ramp would be a bigger project than the Great Pyramid itself. Like any modern construction project, these are logistical issues the Egyptians would have had to overcome. This is the core of engineering, trying to solve problems with the tools at hand, and now we have to reverse engineer this problem without knowing exactly what tools the Egyptians had. One of the most convincing theories I have seen from French architect Jean-Pierre Houdin may hold the truth for the pyramid's construction. Jean-Pierre theorised that this external ramp was used to construct up to the height of the King's Chamber at around 43 metres, allowing the heaviest granite stones used to be hauled up this ramp. Granite has often been used in grand historic buildings for its superior compressive strength, allowing the buildings to grow in size. Here, the granite was tasked with supporting the immense weight of the pyramid above the King's Chamber. At this height, the majority of the volume of the pyramid is completed, but we still need a way of transporting those final blocks into place. This is where the innovative part of Jean-Pierre's theory comes in. He proposes that while the first 43 metres was being constructed, the workers also built an internal ramp, which would transport material recycled from the exterior ramp to the top of the pyramid. Now, this theory should be easy to prove. The interior ramp should still exist, but the pyramid is a protected structure. We can't simply take it apart and see what's inside, but we do have tools that can peer inside the internal structure without damaging it. One team used microgravimetry in 1986 to measure the density of different sections of the pyramid. This research produced this image, showing a strange pattern where the green indicates lower density, which closely matches the pattern of Jean-Pierre's predicted internal ramp. I believe this is the most convincing theory to date, but it is yet to be confirmed or disproven. The mystery of the pyramid's construction may remain a mystery forever, but you can explore this mysterious world in Assassin's Creed Origins, which is out today. I fell in love with the Assassin's Creed franchise when I got to explore Florence in Assassin's Creed 2. It gave me a unique insight into this distant world, and I got the exact same feeling exploring Egypt in Assassin's Creed Origins. They are even including a mode called Discovery Tour to turn off the violence and give you guided tours around this beautiful recreation of the past. I really enjoyed the game. If it sounds like something you are into, check it out with the link in the description. As always, thanks for watching, and thank you to my Patreon supporters for helping this channel exist. If you want to see more content from Real Engineering, the links for my social media accounts are in the description. I just gave a sneak peek for next week's video on Instagram, so if you're interested, check that out.